Hey kids, today we're going to cover D6, D7. We didn't do anything on D8. We had a work day while the ACT test was be giving. And we're going to do D9 and D10. Okay, so D6, 7, 9, and 10. Now, this is the second half of your review for your final. All right, now there are 29 questions total on those days. I counted them up. Let's see how quick we can go through them, okay? Let's try to be done in under 30 minutes. All right, question number 1. 3 rectangular bricks with the same weight but different dimensions are placed on the ground. The force exerted by the ground on each of these bricks, if any, will be the greatest in magnitude. Okay, we've got 3 bricks. All right, doesn't matter which way you orient these guys, right? If they all have the same weight, they're all exerting the same force on the ground. Okay, that would be the weight, right? Gravity pulling down on their mass. The ground is going to push back with an equal force. So the same force in all 3 situations, right? Force exerted by the ground on each of the bricks will be the same in magnitude. That is the correct answer. Okay, it doesn't matter if it's longer, wider, or taller. It doesn't matter. Okay, the weight's the same. The force by the ground on the bricks is the same. All right, question number 2. There are 4 forces acting on an object. 18 newtons in the upward direction, 18 newtons in the downward direction, 36 newtons left, and 12 newtons right. All right, let's draw another block. Okay, remember we did force balances in class one day. We got a force going this way, a force going that way, a force going that way, and a force going that way. Okay, 18 up. All right, newtons up, 18 newtons down. Those guys are going to cancel each other out. We got 36 newtons in the left direction, so 36 newtons this way, and 12 newtons in the right direction. Okay, so the net force is going to be 24 newtons that way. Okay, 36 minus 12 is 24, so 24 newtons in the left direction. All right, let's go on down to number 3. All right, number 3 right here. Which of the following changes in the net force acting on an object would cause the object's acceleration to decrease 3 times? Okay, you have to go back to Newton's laws of motion for this. Right? His law of motion, the second one, says that force is equal to mass times acceleration. If I am going to have that object's acceleration decrease 3 times, right? A is going to decrease 3 times. I have to decrease my force 3 times, right? Because my mass of my object is going to stay constant. All right, so I'm going to decrease the net force 3 times. All right, there it is. Okay. There's nothing squared in here, so we're not going to decrease it 3 times or 9 times. Sorry, 9 times. All right, question number 4. Consider an object in 2 different situations while moving at a constant speed in a straight line in the same direction, situation 1, and while at rest, situation 2. The object will have inertia in both situations, okay? Inertia, as we said in the notes, is related to mass. All right, it's going to have mass when it's moving. It's going to have mass when it's sitting still. Either way, it's going to have inertia. So situation 1 and 2, it will have mass. We'll have inertia. Right? It's one of Newton's laws of motion. Okay. Objects always have inertia. Okay, if it has mass, it has inertia. All right. Question number 5. An object is moving in a straight line at a constant speed without changing direction. Based only on this information, which of the following conclusions will best be made about the forces acting on this object? Okay. We have an object here, and it's got a constant velocity, right? And it's moving in a straight line. Right, an object in motion will continue to remain in motion unless acted on by an unbalanced net force. An object at rest will remain at rest unless acted on by an unbalanced net force. Okay, so the sum of the forces will be 0. All right, the forces are all balanced. They don't necessarily all have the same direction. They don't necessarily all have the same magnitude. There might not be any forces. Okay, and the sum would not be non-zero. It'd have to be 0. All right, balanced forces. Great, moving on. All right, question number 6. Here we are. Which of the following transportation structures will have the greatest tendency to resist a change in its state of being motionless? This is an EOC test question. All right. A bicycle, a bus, a golf cart, or a jumbo jet? Well, the jumbo jet is actually heavier than a bus. I know it's kind of tricky to know sometimes, but there's your answer. All right, a jumbo jet. Pick the heaviest object. It'll have the greatest tendency to resist a change in its state of being motionless or state of being in motion. Either way. All right. More mass, more inertia. That's what that question is about. Question number 7. Suppose a tennis player's racket makes contact with the tennis ball. Compared to the magnitude of the force exerted by the ball on the racket, the magnitude of the force exerted by the racket on the ball will be, they're going to be equal forces in opposite directions, okay? So it's going to be equal. All right, now when you talk about magnitude, you're talking about the amount. All right, so if I have a force going this way, and I have a force going that way, this one's 12 newtons, and this one's 12 newtons, okay? These are equal forces in opposite directions, okay? It means the magnitude is equal. The number is equal, okay? The direction might be different. All right, that's 7. Let's do, oh, hey, that's all of that one. Okay, now we're on D7 review, Q4. And again, I printed these out. I previewed them, so they may be shuffled. They may not be the exact same order you saw them. I'm not sure. Okay. Trucks 1 and 2 are traveling at the same constant velocity, but truck 1 energy due to motion is 2 times less than that of truck 2. That is because truck 1's mass is... All right, let's think about this. We got truck 1, all right, and truck 2. Do you love my trucks? Perfect squares, right? All right. They're traveling at the same constant velocity. Okay, so these guys are both moving at the same velocity. Truck 1's energy due to motion is 2 times less than that of truck 2. Well, kinetic energy is equal to 1/2 times mass times velocity squared. Okay, the velocity is the same. How could that truck have less energy than this truck? Well, it's going to have to be because his mass is less. Okay? All right. Truck 1's mass is half, 2 times less than that of truck 2. Here we go. All right. Make sure you read the problems carefully. The wording can be confusing sometimes. I just pulled these off the EOC, right? Truck 1 and 2 are traveling at the same constant velocity. Truck 1's energy due to motion is 2 times less than that of truck 2. Therefore, truck 1's mass is 2 times less. All right. Sphere A and B have the same diameter. So we got 2 spheres the same size, right? There's B, there's A. Sphere A weighs twice as much. So let's make mass of this guy equal 2 and the mass of this guy equal to 1. All right? That works. If the spheres are placed on the same flat surface side by side, compare their gravitational potential energy. Look, there's my surface. All right, we know that potential energy equals mass times gravity times height. If they're on the same flat surface, they have the same height, so it doesn't change. We're not changing gravity, okay? So the mass of that guy is twice as much as the mass of that guy, so his potential energy is twice as much as that guy, okay? All right. Wait, spheres B's gravitational potential energy will be less, okay? B is going to have less mass than A. Make sure you read the problems carefully. They might try to trick you, okay? Read the problems carefully, think it through. Don't rush like I am right now. Okay, question number 3. We have a roller coaster car. Oops, there we go. Roller coaster car covered the distance from A to B in its track. At both these points, the roller coaster car had non-zero potential and kinetic energies. So potential energy does not equal, does not equal sign 0. Kinetic energy does not equal 0, both places. Okay. The difference between the car's potential and kinetic energies, potential minus kinetic, so we're going to do PE minus KE, all right, increased. So that's important to know. That's going to increase. Okay, going from point A to B. Okay, so we're going to go from A to B. Now, you could think about this track we drew in class, right? We did something like this. All right, where can we increase this difference, right? Well, if we start down here, this potential energy would be low. Its kinetic energy would be high. Up here, its potential energy would be high, and its kinetic energy would be low. So making that trip from A to B is going to cause this to increase. All right, so point A was located lower than point B. That's this choice right here, B. Okay, these just take a little bit of thought, reasoning, draw pictures. I'll give you scratch paper for your final. Write stuff down, think them through. Okay. All right. Question number 4. If you do that, you'll get the best grade you can. Right. You just read them and then try to pick an answer. You might get it right, you might not. All right. Question number 4. If an unopened cereal box placed vertically on a lower shelf of the kitchen cabinet is moved and placed vertically on a higher shelf, potential energy of the cereal box is going to remain the same, increase only, decrease only, or increase or decrease. All right. All right, so the key is that this cereal box is here, right? We're going to move it up, place it here. Now, if we move it to a higher shelf, but we rotate its orientation, remember, it's possible that it could increase or decrease. But it says that it's placed vertically on the lower shelf and placed vertically on the higher shelf. So no matter what you do, if the shelf is higher and it's in the same orientation, it has to increase, okay? So it's going to increase only. All right, the figure below shows a free-falling object at 2 different heights above the ground. Okay, it has not hit the ground yet in either position. What happens to the sum of potential and kinetic energies of this object during its fall from height h1 to h2? Okay, mechanical energy is equal to kinetic energy plus potential energy. All right, mechanical energy is conserved. All right, so mechanical energy is conserved, so the sum is going to be stay the same. All right. And let's see, it remains the same, Oh, but why? because the decrease in potential energy cancels out the increase in kinetic energy, right? That is true. As the object falls, the potential energy goes down and the kinetic energy goes up, okay? So as the object is falling, the potential energy is decreasing and the kinetic energy is increasing, right? It's getting faster and faster as it falls, okay? Gravity is an acceleration, right? It actually accelerates towards the ground. Okay, we are on day 9. Okay, review, Q, let's see, where are we? 5. All right. I think there's 10 questions here. Let's stop the video and we'll start a new one.